begun. You got me jumping like
Boom shakalaka, boom shakalaka, boom shakalaka, boom shakalaka, boom shakalaka, boom shakalaka.
wanna hold you down.
What is aquifer? Aquifer are bodies of rock or sediment which groundwater is able to move or flow.
Aquifer is an underground rock formation through which groundwater can easily percolate. So there are two types of aquifers: confined aquifers and unconfined aquifers. So first, what is confined aquifers? Is an aquifer that is bounded above and below by confining beds. So confined aquifer are those in which less permeable material exists that prevents the water from seeping to the ground surface directly located above. And it is a body of distinctly less permeable material. Confined aquifer is an aquifer sandwich between two aquifers. Confinement can raise the water pressure in an aquifer to produce an artificial bed. Confined aquifer. So this is an aquifer whose upper boundary is the water table. So confined aquifers are those into which water seeps from the ground surface directly above the aquifer. It also called the water table aquifer. It usually occurs near the ground. And
Hello, I'm Ara and I'm here to talk about the it operates. How does an aquifer work? An aquifer is filled with moving water, and the amount of water stored in the aquifer can vary from season to season per year. Groundwater may flow through an aquifer at a rate of 50 feet per year or 50 inches per century depending on its permeability. Permeability is the capacity of solid to allow liquid or gas to pass through. No matter how fast or slow, water will eventually discharge or leave an aquifer to replenish or recharge it. What are the recharge and discharge zones? Recharge zones are typically at higher altitudes but can occur wherever water enters an aquifer, such as from snowmelt, river and reservoir leakage, or from irrigation. Meanwhile, discharge zones can occur anywhere. It occurs not only in springs near the stream, but also in wetlands at low altitude. Now, let us know the difference between an aquifer and an aquitard. An aquifer is a saturated region of the subsurface that produces an economically feasible quantity of water to a well or a spring. Example of a good aquifer is sand and gravel or a fractured bedrock. Meanwhile, an aquitard is a zone between aquifers that restricts the flow of groundwater from one aquifer to another. A completely impermeable aquitard is called an aquiclude or an aquifuge. Aquitards comprise layers of either clay or non-porous rock with low hydraulic conductivity. Both aquifers and aquitards are included in the saturated region underground. How does groundwater move in aquifers? When new surface water enters an aquifer, it recharges the groundwater supply. Recharge primarily happens near the mountains, and groundwater usually flows downward from mountain slopes toward streams and rivers. Now, let us know the difference between an aquifer and an aquitard. An aquifer is a saturated region of the subsurface that produces an economically feasible quantity of water to a well or a spring. Example of a good aquifer is sand and gravel or a fractured bedrock. Meanwhile, an aquitard is a zone between aquifers that restricts the flow of groundwater from one aquifer to another. A completely impermeable aquitard is called an aquiclude or an aquifuge. Aquitards comprise layers of either clay or non-porous rock with low hydraulic conductivity. Both aquifers and aquitards are included in the saturated region underground.
Did you know that right under my feet there are thousands and thousands of gallons of water?
This groundwater is found in aquifers. Aquifers are a combination of gravel, rock, and sand. These rocky stones hold the water in the soil. Builders can drill wells into these aquifers to provide water for homes, farms, and industries.
Underground aquifers contain far more water than all the surface reservoirs and lakes in the US, including the Great Lakes. In some areas, the groundwater is the only source of fresh water for people and ecosystems. It does get filled back in, but slowly, over hundreds and sometimes thousands of years. Unfortunately, right now, people are pulling the water out of aquifers faster than nature can refill them.
But now, with new technology, like NASA's GRACE mission, which can measure groundwater levels from space, we can really see what we are doing to our groundwater.
We can see groundwater from space? How is that possible?
The GRACE satellites detect small changes in the Earth's gravity, caused by water moving on and beneath the Earth's surface. Thanks to these satellites, we can now detect where groundwater supplies are being threatened. For example, this map shows the area where aquifers are being sucked dry to water crops during an intense drought. Because of this, the ground in Central Valley of California is actually sinking.
Besides monitoring the level of aquifers, we're improving the ways we can fill them back up. One way is what is called groundwater recharge. That's when we use ponds or wells to put water back into depleted groundwater aquifers. This is really useful during a drought.
Some places, like Santa Clara County, California, are experimenting with ways to put water back into their underground aquifers. Normally, the Santa Clara Valley Water District puts over 30 billion gallons of water back into their aquifers each year. Now they have future plans to use recycled water to recharge their aquifers. This may mean an additional 15 billion gallons of water for their aquifers.
What other solutions can you come up with to make sure that we have enough water in our underground aquifers for thousands of years to come?
How does groundwater move in aquifers? When new surface water enters an aquifer, it recharges the groundwater supply. Recharge primarily happens near the mountains, and groundwater usually flows downward from mountain slopes toward streams and rivers by the force of gravity. The speed of the movements depends on the density of the rock and soil through which the groundwater moves. Groundwater is said to be one of the most important sources of water on Earth. About 30% of our liquid fresh water is groundwater, according to the National Oceanic and Atmospheric Administration. An aquifer may be included in an aquifer system. This is an example of an aquifer system. As you can see, at the top is where we can find the unsaturated region, and below it is the water table or the phreatic surface. I colored it blue so it can be visible. Below the water table is the unconfined aquifer. It is the aquifer whose top is the water table and is more prone to contamination. Beneath the unconfined aquifer is an aquitard, which is completely impermeable and is not porous and does not allow water to pass through. Below it is another aquifer. This one is a confined aquifer. The speed of the movements depends on the density of the rock and soil through which the groundwater moves. Groundwater is said to be one of the most important sources of water on Earth. About 30% of our liquid fresh water is groundwater, according to the National Oceanic and Atmospheric Administration.
Bumaba tuloy.
An aquifer may be included in an aquifer system. This is an example of an aquifer system. As you can see, at the top is where we can find the unsaturated region, and below it is the water table or the phreatic surface. I colored it blue so it can be visible. Below the water table is the unconfined aquifer. It is the aquifer whose top is the water table and is more prone to contamination. Beneath the unconfined aquifer is an aquitard, which is completely impermeable and is not porous and does not allow water to pass through. Below it is another aquifer. This one is a confined aquifer.
An aquifer should be made of gravel, stone, and sand. Groundwater problem. Water, as a valuable resource, is vulnerable to overconsumption and wasteful use.
I think the universe is on my side. Heaven and earth have finally aligned. Days are good, and that's the way it should be. You sprinkle stardust on my pillowcase. It's like a moonbeam brushed across my face.
Relation between the aquifer and the groundwater. So here, I'm holding a sponge and a glass of water. This sponge represents as the aquifer and this glass of water represents as the groundwater. Okay? We can see that the sponge absorbed the water, just like the aquifer.
Water covers 71% of the earth, making it the most abundant natural resource by volume. 97% of the Earth's water is salt water in oceans. Only 3% exists as fresh water, readily available for use by humans, animals, and for agricultural purposes. 3/4 of this fresh water is found in ice and glaciers, rivers, lakes, and atmospheric vapor. The remaining 1/4 of the world's fresh water is an aquifer. Man's most economical source of fresh water is groundwater. Groundwater is formed through the hydrologic cycle. This process can take between a few days to thousands of years for a droplet of water to travel the full cycle. Aquifer are a body of saturated rock which contains water, and there are two types of aquifer: unconfined aquifer and confined aquifer. Water from shallow wells and boreholes come from unconfined aquifer, and they're usually susceptible to contamination due to their closeness to the Earth's surface. Water from industrial boreholes sunk to depths of 80 to 300 meters comes from the confined aquifer, where the water is less prone to contamination. The global concern for the depletion of groundwater is real and can be observed in countries like United Arab Emirates, India, China, and California in the USA, where there is heavy dependence on groundwater for agricultural purposes. In Africa, very little statistics are available, but the increasing use of boreholes and wells by domestic and industrial uses is cause for concern, particularly in cities with a fast-growing population and urbanization like Lagos. Excessive mining of groundwater without adequate replenishment can result in land subsidence and the consequent effect on buildings. A depletion of groundwater resource in an area like Lagos can easily result in irreversible saltwater intrusion into the confined aquifer, where the corporation and other industrial miners get a good proportion of their water. Unregulated well and borehole construction can create health hazards, which may result in epidemics from groundwater contamination. The importance of water to human life cannot be overstated. Government therefore has a responsibility to guard its exploitation and ensure passing on a healthy water resource.
So I'm here to discuss one of the groundwater problem, the saltwater intrusion. So first of all, what do you mean by saltwater intrusion? So saltwater intrusion happens when saline saltwater and fresh water mixes together, resulting to the contamination of water. So a natural boundary exists between groundwater and saline saltwater below. Groundwater extraction promotes the lowering of the local water table, which slowly reaches the boundary. So when the water So when the water reaches this boundary, salt water and fresh water mixes together, which makes the water unsafe to drinking. So as I said earlier. So, but the question is how we can prevent those groundwater problems, the saltwater intrusion. So, as we all know, water is very important. Drinking water is considered a luxury in dry areas around the world. So we should so so how we can prevent the saltwater intrusion? So the balance between recharge and extraction is the key to the prevention of some saltwater. Thus, for some groundwater problems like saltwater intrusion. And even in simple ways, just like proper waste disposal and good landfill design decreases the groundwater pollution and contamination. And salt and groundwater is considered as a renewable resources. But just like any other valuable thing, we must do our best to protect and preserve it so that future generation may also enjoy it as well. So that's all. Thank you.